All right, so how do we solve a quadratic like this? Well, I would first try to factor it. 3 times 4 is 12. Unfortunately, there isn't anything that multiplies to 12 and adds to 10, so factoring is out of the question. Instead, we're going to use the quadratic formula. Quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, what does this come from? The number in front of x squared is your a value. The number in front of x is your b value. And the constant added at the end is the c value. So entering it into this equation, which will solve it for me, x equals negative 10 plus or minus the square root of 10 squared minus 4, always minus 4, times a times c, all divided by 2a. 2 times 3 means that there's a 6 down in the denominator. So here's my solution. That looks pretty messy, so we're going to clean it up a little bit, specifically underneath this square root sign. So 10 squared minus this, 4 times 3 times 4, that would be 48. 100 minus 48 means that that's 52. So this green looks better. I can't simplify anything numerator to denominator yet because I'd have to divide both of these terms in the numerator as well as that one term in the denominator all by the same thing, and nothing will go into them. But square root of 52 can be broken down into the square root of 4 times the square root of 13, which makes it 2 root 13. So I'm going to write this as negative 10 plus or minus 2 root 13 over 6. At this point, all three of those terms can now be divided by 2. So it's going to be negative 5 plus 1 square root of 13 over 3. And there's really two answers here. When we solve a quadratic, there's almost always going to be two answers unless it's a double root. So our two answers here are negative 5 plus the square root of 13 over 3, which would give us one of the solutions. And the other one would be negative 5 minus the square root of 13 over 3. Turns out if we looked at the decimal equivalents of these, both of them would be negative, but we have our two solutions using this quadratic formula.